Unit 1, Part 1, Functions and Function Notation. Well, if you remember, we covered this back in Algebra 2 also, and it's been a concept since Algebra 1 that in order for a relation to be a function, graphically, it must pass the vertical line test. Whoops, I don't know why I capitalized that. The vertical line. That means all the x values only get used once, and they don't have multiple x values with different y values. In other words, the x values cannot repeat. Each x is only used once. Y values could repeat, but x values cannot repeat. Then, in order for an equation to be a function, if we're talking about equations, if it's functions involving x and y, when we have equations that have x and y, the goal is to solve for y. If you can solve for y and not have an even root, or if you have an even root, you're going to end up with when you solve for y, then you have to take a root, a square root, or a fourth root, or a sixth root, and any even root is going to have a plus or minus. You're going to have a positive and a negative solution, which means it has positives and negatives of the same value, so it's not a function. But if you can get y equals all by itself, and you don't have to get a positive or negative, then it's going to be a function. Now, things to remember that we talked about in mathematics. When you're talking about domain, we read it from left to right, and range is read from bottom to top, so left to right, but this way. We want to just left to right. We don't need both arrows. Just left to right. Range is read from bottom to top, going upward. And a bracket means including the endpoints. So I'm just going to put including, but on the notes I put including the endpoints. A parentheses means not including or does not include. Does not include the endpoints, whatever endpoint is there. Does not include. A U means for union or for or. Then you have more than one interval. Domains from left to right, range is from bottom to top. If it's 1 to 1, it must pass both the vertical and horizontal line test. Both. The vertical and horizontal line tests. I wrote too big and sloppy. Sorry, my handwriting's bad, but luckily you're listening and then you get that information. Okay, number 1 says draw an example of a graph that's a function. Well, just make something that passes the vertical line test. There's a function. There's a function. There's a function. Any of those would work. Then it says 1b over here on the right says draw an example that's not a function. Well, that's not a function. That's not a function. A vertical line is not a function because every point gets hit multiple times on it. Number 2 is using this mapping over on the right. That's all nice and colored for you. Which ones are a function? Which ones do the x's not repeat? Well, none of those x's repeat, so A works. A repeats. So B does not work. This one, none of the x's repeat, so C works. And D works. So A, C, and D. Then what are the domain and ranges for? We don't want to do all of them. We'll do 3C. The domain is going to be the input values, which is just a set of numbers, or a set of letters in this case, A, B, C, and D. A, B, C, and D. All of those are inputs. The range is the outputs. Range. I can't write, sorry. The range, that's horrible looking. I apologize. The range is the outputs, which are just P, Q, and R. P, Q, and R. That's where my comma is supposed to go. And those are my braces that you put them in. Okay. I'm clearing that off there because my handwriting was atrocious. So we're going to clear that off. And now we're going to move on down to number 3. Which ones are functions and equations? So which ones could we solve for y equally without a plus or a minus? I'll give you a hint. That's an even root, even number, so you have to bring in an even root. So first thing I would do is subtract the 6x cubed. So negative 2y squared is equal to 7 minus 6x cubed. I would divide by negative 2. And then you end up with y squared is equal to 7 minus 6x cubed over negative 2. Then to get rid of a square, you bring in a square root. But anytime you bring in an even root, you have to remember plus or minus. Well, that means it is not a function. Not a function. This one you could solve. You subtract 7x, subtract 8x and divide by 7. You get y equals. So yes, that's a function. This one you could take a cube root. That's an odd root. An odd root, yes, that's a function. This one you would subtract 1, gives you x minus 1 equals square root of 2y. Then you would square both sides. And then you would divide by 2. You get y all alone. There's no, yes, it's a function. Then, last thing, x equals 4 is a vertical line. No, that's not a function. So that's the first part. Are they functions? Then, the second part says, if it is a function, are they one-to-one? So let's go back to the yeses. Is this one-to-one? Well, this is a line. So yes, it's one-to-one. This one is a cube root graph when we solve for y. So yes, it's one-to-one. This one will be x squared when we solve for y. If it's squared, that's a parabola. No, that's not one-to-one. And the others are no, so we don't have to worry about those. And so there are the answers to front page. So let's go through the notes on the second page. On number 4, determine which of the graph, whether the graph is a function. If so, no, then determine the domain and range of each. So whether it's a function or not. So, is this one a function? Is this part 4a, is 4a a function? Well, that is a logarithmic function to be exact. So yes, it is a function. It looks very vertical right here, but it's designed to show that it's an asymptote that's getting closer and closer and closer to it, but it's not straight up and down. Is it a function? Yes. Is it one-to-one? Yes. Vertical line and horizontal line only hit it once. The domain, and we're going to practice different notations on different ones of these just to make sure we review those notations. Inequality, well, this graph only exists after 0 for the domain. X is not equal to 0, but anything after 0 counts. So it's 0 to infinity. So that's interval notation, but inequality, you would just say x is greater than 0. The range is the y values, which go down forever and up forever. So the range is all real numbers. Now, it didn't ask for it, but interval notation, we would have said 0 to infinity. And this would have been negative infinity to positive infinity. But that's interval. We wanted inequality notation. So here's the official answers on that one. 1b is the rational parent function. Yes, it's a function. Is it one-to-one? Yes. Vertical lines only hit it once. Horizontal lines only hit it once. Set builder is going to look a lot like this one. So this one, the domain is everything before 0 and everything after 0. It just has a vertical asymptote here. So in interval notation, we would say negative infinity to 0, union with 0 to infinity. That's interval. But for set builder, we say the set braces is what that's supposed to be. X such that we want x is less than 0. Well, it's actually everything except 0. So let's just say x is not equal to 0. That's everything less than 0 and everything greater than 0. The range is the exact same way. It has a horizontal asymptote that it never touches. It's everything below the y-axis and everything above the y-axis. So it's the set of numbers y such that y is not equal to 0. And there's our set builder notation. And C is a absolute value function. So yes, it's a function. It passes the vertical line test. Is it one-to-one? It fails the horizontal line test. So no, it is not one-to-one. The domain is everything except that hole. It goes left forever. You can assume graphs that go to the edge have arrows. So it goes left forever and right forever. It's just everything except 1. So the domain is the set of all numbers x such that x is not equal to 1. The range goes up forever. The lowest it goes is 2, negative 4. It just doesn't touch it. So the range is y such that y is not equal to. Y is just always bigger than. Oh crap! I hit the wrong button. Sorry. Y is greater than negative 4. And there is the range. So let's move on to number 5. Number 5, we have this lovely graph here. And what is the domain? Well, I notice it starts at -7. There's a hole that we have to skip at -5. So we're going to go from -7. So the domain starts at -7, goes until -5, then it's a parentheses. Then it keeps going after -5 until our vertical asymptote at -1. It doesn't touch the vertical asymptote. It picks back up after the vertical asymptote and goes from -1 until 3. Uh-oh, I wrote too big. It touches at 3. And then the last thing it does is at 3 on, but this version from 3 on, it's not. It's an open interval, so it's 3 to infinity. So parentheses 3 to infinity. Now, here's a catch. That is not the best way to write this now that I just thought about this for a second. This, say, if we're looking at the x values, the x values were here, they skip here, they go here and skip, and then here, they jump, but all the x's are actually covered. There is no x value not accounted for. So really, I need to undo from -1 on, even though there's a jump here, the x values are all accounted for. We have all these x's before 3 and all the x's after 3 and the x at 3. So it just goes from -1 to infinity. So I almost told you wrong. Sorry about that. The range, let me clear this graph off because I've scribbled all over the place here. The range is the y values, and we're going to go from bottom to top. Bottom is -6. It goes up. I see a gap here, but the gap is covered over here, so it's consistently covered, all y values until, well, it just goes up for forever because that's a vertical asymptote there. So the range is from -6 to infinity, and it does include -6. Now, increasing intervals are from left to right. When is this graph going upward? So if this were climbing a mountain, climbing a hill, climbing a slide, here we're going upward, here we're going upward, here we're going downward, and then here we're going upward. So we want these upwards. So our up, and you look at the domain values. So it's the same domain. So increasing intervals went from, and they don't, you can use brackets, but they usually for increasing and decreasing, it's always parentheses. We don't worry about the endpoints. So from -7 to -5, we were going up. From -5 until -1, we were going up. And the last time we're going up now is from 3 to forever. So from 3 to infinity. And those are our 3 increasing intervals. When is it decreasing? Well, the only time we talked about it going downhill was if it were a slide, you'd be writing that slide down, would be from here to here, which was from -1 till x equals 3. So from -1 to 3. And like I said, we don't worry about the endpoints. Okay. Last few things on this page to talk about is what is the domain of a linear function? That's something you should know by now. It's a line. Lines go on forever and ever. So the domain is all real numbers. So -infinity to +infinity. Unless you're talking about a vertical line. The domain of a vertical line is just one number, whatever that x value is. But most lines, if it's any other line, it's going to be all real numbers. So that's just something to keep in mind there. Now, number 7 says, for the function y equals 2x squared minus 5, with the restricted domain, what is the range? So let's just make a little sketch of this graph first. 2x squared is a parabola that's stretched but moved down 5. So I'm going to go down 5 and then make a slightly skinnier parabola. So that's what it is from -infinity to +infinity. But we want to start it at -2 and end at 10. So start at -2, whatever that y value is, and end at 10. Well, the lowest this graph's going to go is right here. So our range is going to go from lowest to highest. So it's going to go from -5 to up forever, but we're not going up forever. We're going up until 10. So at 10, if we plug in 10, we get 100. We get 2 times 10 squared, which is 100, times 2, which is 200 minus 5. 200 minus 5 is 195. That's as far up as we're going to go. And it's not including the 10. So it's to the 10, but it doesn't count it. So that's as far up as we go. The lowest, if we plug in, just to see how high it was on the left, if we plug in negative 2, that's 2 times 2 is 4. 4 minus 5. 4 minus 5 is negative 1. So it's just right here. The graph just starts here and goes up. So the range, let me erase the extra stuff that's on here. This graph goes from here up to here, but we always go lowest to highest. And the highest was at 10. Okay, let's go to the next page. We have 3 functions. We have a table, a graph, and an equation. So this is the f function, this is the g function, this is the h function. Pay attention because that tells you where to go. So this first one says go to the h function. When the input or x value is 3, what do you get? So we have to go to the h function and put 3 in for x. H of 3 is going to be 3 squared minus 2 times 3 minus 8, which is 9 minus 6 minus 8, which is 3 minus 8, which is negative 5. So if I didn't mess up, you get negative 5. I'm going to check myself with the key. Okay, good. I agree with the key. Now, 8b says go to the f function and plug in 4. Go to the f function and plug in 4. What do you get? You get 8. Straight from a table. It's easy to read. Just like, let's go to g. G says go to the x value of negative 2. What is the y value? That y value right here is also negative 2. So tables and graphs, you go straight to x and get the y. 8c, though, says we need to go to h, and you plug in 4b this time. So plugging in 4b is going to be 4b squared, because we have to square it, minus 2 times the 4b, and then minus 8. Well, 4b times 4b is 16b squared. Negative 2 times 4b is negative 8b, and then minus 8. And that's all there's no like terms. We're done with that one. And 8e says solve for x when the function equals 40. So we're going to take 40 and put it right here where the function is. So I'm going to write that 40 is equal to x squared minus 2x minus 8. Well, to solve a quadratic, you have to get it equal to 0. So let's subtract 40. And we have x squared minus 2x minus 48. Now it's equal to 0. And to solve a quadratic, we try to factor that. Do you know 2 numbers that multiply to give you x squared? Well, that'd be x times x. But 2 numbers that multiply to be negative 48 that at the same time add to be negative 2. Well, I would go with 6 and 8. 6 times 8 is 48, and negative 8 and a positive 6 would be negative 2 when you add. So that tells me x is negative 6 when you solve it, because you say x plus 6 equals 0. X plus 6 equals 0, subtract 6, you get negative 6. And then x minus 8 equals 0. Add 8 to both sides, and you get x equals positive 8. So negative 6 and positive 8 are our solutions. And number 9 says, okay, what is m with a plus h plugged in when you have this function? Well, here's the m function. All we're going to do is replace that x with a plus h. So that is going to be square root of 2 minus a plus h, and then a plus 5. The most you can really do to that is distribute the negative sign. So there's no like terms to combine. We can't solve a function. So we have 2 minus a minus h, and then plus 5 not inside this root. That's all we can do to that. So we are now done with that one. That one's actually kind of easy, I think. And number 10, we have a graph shown. What is the input at negative 1? So you go to negative 1. Well, I see 2 possibilities. We want the solid dot, because that's the actual y value. So at negative 1, we get a y value of 0. And then at g of 2, says you go to the graph in 2. What is the y value? The y value is negative 4. So that one has a y value of negative 4. And we've finished number 10. And I believe this is the last page, or no? Is it? We have one more page to go. This is the last page now. So yeah. So on this last one, when you're doing domain of a function, the main takeaways is normally you start with the assumption, let's let the domain be all real numbers. The domain, any number you can put in for x is almost always going to be everything, unless there are certain traits, the right criteria that have to be met. you can't divide by 0. So if the denominator, if there's a fraction, the denominator can't be 0. So that restricts, we're no longer all real numbers. If you have a square root that's an even root, it can be any even root. It cannot, we normally deal with squares, but any even root, you can't have a negative inside there because then you get imaginary solutions. So we want, those have to be greater than or equal to 0. So 0 or positive. And then for logarithms, it has to be greater than 0 because logs only exist after 0. So those are the only 3 restrictions that I can ever think of in math, but the main 3 that you'll deal with. So for this first one, we have a square root. The inside of a square root cannot be negative. So we look at that inside and go, hey, this inside here, negative 3x minus 2, has to be bigger than or equal to 0. That's our only restriction. And so now we solve that, and that'll tell us what the domain is. So add 2 and divide by negative 3. So let's start with adding 2. Divide by negative 3. And when you divide by a negative, an inequality changes directions. So that makes it negative 2/3. So that says from x is less than or equal to negative 2/3. So our domain in interval notation is everything before negative 2/3. So negative infinity until negative 2/3. And not a bracket because it's not, oh, it is equal to. So a bracket because it can be less than or equal to. So everything before negative 2/3. There's our domain. On the next one, right beside it, we have 2 things we have to look at. One, we have a square root. X plus 4 has to be bigger than or equal to 0. You can't have a negative inside a square root. Subtract 4, that tells me x has to be bigger than or equal to negative 4. But also, the bottom of a fraction can't be 0. Well, x squared minus 16 cannot equal 0. What makes that 0? Well, let's factor it and find out. That's a difference of 2 squares. You get x plus 4 and x minus 4. So those can't be 0. So the x can't be negative 4, and x can't be positive 4. And we've already said that x has to be bigger than or equal to. So the equal to is now thrown out because it can't equal it. So we can't be, it's everything bigger than negative 4, but it has to exclude 4. So that means our domain is everything from, not infinity, from negative 4 on, but not a parentheses. Not a bracket, sorry. Not a bracket, just a parentheses because it can't include it. It goes until positive 4, and then it picks up after 4, and it goes on forever. So there's our domain from negative 4 until positive 4, and then 4 to infinity. That says everything bigger than negative 4, and don't count negative 4 and positive 4. And so that is what we've done on that one. Let's go to the next one. This one, I look at the top, and I only see is t minus 5. Well, the numerator can be 0, the numerator can be positive or negative. There's no restrictions there. But we have a denominator that's a square root. A square root is normally greater than or equal to 0. But the catch here, it's on the bottom of a fraction. And we said the bottom of a fraction can't equal 0. So this has to only be greater than 0. Whatever's in the bottom can't be 0, and it's a square root, so it can't be negative either. So it has to be just greater than 0. So we say 2t minus 3 has to be greater than 0. So we add 3 to both sides. 2t has to be bigger than 3. Divide by 2, and you get t is greater than 3 halves. So that means from 3 halves to infinity, but don't count the endpoints. And last one in this section, same style. We want to know, doesn't matter what the top is, the bottom can't be 0. Well, let's factor that bottom first. That is x times x plus 6 and x minus 6. It's another difference of 2 squares. So I see this can't be 0, this parentheses can't be 0, and this can't be 0. So x cannot be 0, x cannot be negative 6, and x cannot be positive 6. So in intervals, that means we go everything from the left until the first number you come to is negative 6. Put a parentheses, don't count it. And then from negative 6 to positive 6. And then from 6 to infinity with parentheses. All parentheses because there's no equal to. That is our domain for number, well, the last one in this section. Okay. Final picture here. We have a graph, and we have some traits we want to answer. We're going to kind of tie it all together. We can assume there are arrows on the end when it goes all the way like that. So the domain, this goes left forever. So if we're talking from left to right, we're coming along. All these x values exist until right here. I see Everything before 1 we have x values, and everything after 1 we have x values. So our domain is, and it says interval notation, so from negative infinity to positive 1, and then from 1 to infinity. That's our domain. Our range is y values, and I see a lowest y value here, and then it goes up forever. There is one open gap here, but there's a filled-in gap here, so the range is actually everything from this y value, which was -4, on up forever. So from -4, and it is equal to it because it actually touches down that line, -4 to infinity. And then the y-intercept is, where does this graph touch the y-axis? Well, that's right there at y equals 4. So as an ordered pair, that's 0, 4. The x-intercept is, where does it touch the x-axis? Well, I know that one's a whole number, x equals 2. So 2, 0. This other one, we're going to let you assume for now. That kind of looks like a half, so I'm going to say -1.5. So -1.5, 0. That's 1-ish. This one you get to guesstimate. Later on, we'll do some math and actually calculate and be more precise on those things. But that one we can just make an assumption for now because we're just practicing this skill. And then, what is the function when x is -2? What's the output when the input is -2? Well, -2, what is the y value? The y value is right there, which is y equals -4. So -4 is the answer. And this one, when the output is 6, what was the input? When does y equal 6? So I go up to 6, and what was the x value? Well, that was x equals 5. So, x equals 5. The computer ran slow for a split second. And is this function 1-to-1? No, it does not pass the horizontal line test at all. So no. Horizontal line hits it, boom, multiple places. And let me clear off my. Oh, that's not a script. I was trying to erase everything. Sorry, I picked the wrong utensil to write with. I use the mark highlighter instead. Let's go to that highlighter. When is this function less than 0? When are the y values less than 0? They're less than 0 when they're below the x-axis. When is it down here? And that happens from everything before that -1.5. So -infinity to -1.5. And it's not equal to 0, so there's no bracket. When is it greater than or equal to 0? Well, greater than would be when it's above the x-axis. That's not red. I thought I switched colors. Oops, I switched the wrong thing. That's why. When it's above the x-axis, which is, if we clear that all off, just to talk about for a second, let me clear that and see. It's above the axis here, and it's also above the x-axis here. So that would be from, let me get a pen again, -1.5. Oh, it is touching, so it's a bracket, not a parentheses. -1.5 until the x value doesn't exist at 1, so until 1. And then anything after that, so 1 to infinity. And the very last thing, when is the y value -4? And I'm looking, when is y -4? That is all of this line. So it's from -infinity until it stops being -4 is at -2. So from -infinity to -2. And it does equal to there. And that is everything you need to be able to do this assignment. Good luck to you.